Okay, this is homework help for Unit 4, Objective 3. I'm going to start with Worksheet 3. So let's take a look at question number 2. So for number 2, in order to be able to add or subtract radicals, these have to be the same. Now that's not true for multiplying, right? So I'm going to try to see if by simplifying these, if that will get these to be the same radical. So for 50, I could break that up to 25 times 2. And for 8, I can break that up to 4 times 2. So then I don't know the roots of 2, but I do know the square root of 25, which is 5, and then 2 stays under the radical. The square root of 4 is 2, and the 2 stays under the radical. So I'm going to go ahead and multiply the 11 and the 5 together first. And then I can combine my coefficients, so that would be 55 plus 2, and then my radical stays the same. Okay, right, and then let's take a look at number 4, or let's do number 5. Okay, so question number 5. So these are different, right? So that means I can't combine them, so I'm going to try to simplify them first. So for here, I'm going to rewrite x to the 5th. So 25 I don't have to rewrite because I actually know what that root is. But I need to split off one of the x's, so that would be x to the 4th and x, because I have an odd power. And then 49 I do know the root of, so I'm not going to rewrite 49. And then x can't be rewritten. Okay, so that's what I have. So all I've done at this point is rewrite x to the 5th as 4 and 1. Okay. Now I'm going to take the root, so I don't know that root. So 25 is 5. Take half of 4, which is 2. And then x stays there. The square root of 49 is 7, so I have 3x squared already. So 7, and I don't know the root of x. Then I can multiply these two together. And then I still have root x. So now these are both root x's, so I can go ahead and combine. So 5x squared plus 21x squared. And then I still have a root x. Okay? So that was question number 5. Okay, and then let's take a look at question number 9. So this is squared, so that means I want to write it side by side. And then from there, I'm going to go ahead and distribute. Okay, so squared meaning I have two exactly the same, so they should not be opposite, but the same, both adding. And then this 3 has to multiply to both of these terms. So 3 times 3 is 9. And then here I'm going to multiply the integer values, right? The 3 and the 2 together. So 3 times 2 is 6. And the 3 does not distribute to the radical, right? So it's just going to stay root 3. And now I'm going to multiply 2 root 3 to both of these terms. So I multiply the integers, so 2 times 3, and then it will stay root 3. And then 2 times 2, and then root 3 times itself will be just 3, right? Or square root of 9, which is just 3. Let's get you to see what that was, sorry. So 2 times 2 is 4, and root 3 times itself is just 3. So now I can combine these terms together. So 6 and 6 is 12, and the radical stays the same. This means I have 6 root 3. I have 6 more root 3, so altogether I have 12 root 3. And then 4 times 3 is 12. And then I can add 9 and 12 together. And then these don't combine. So that's off of the worksheet. Okay, so let's go ahead and take a look at some of the bookwork. Okay, so some of these I had already worked out ahead of time, so I'm just going to kind of talk you through them. So this is question number 7. So this is just like the worksheet 3 problem I just did. So because it's squared, I want to write it out twice. So root 3 plus root 5 times itself. Make sure these are exactly the same. Both of them are adding. And then I'm going to distribute root 3 to both of these terms, and then root 5 to both of these. So root 3 times itself is just 3, root 9, which is 3. And then even though these are different, doesn't mean I can't multiply. It does mean I can't add, but I can definitely multiply. So root 3 times root 5 is root 15. And then root 5 times root 3 is root 15. Root 5 times root 5 is the square root of 25, which is just 5. I can add the 3 and 5 together, and then there's an implied 1 here, and these are the same, so I can add them. If these had been different, like say that was 15 and that was 12, I couldn't add them. So 1 plus 1 is 2, and then I still have a root 15. So that was question number 7 on page 443. And then on page 446, so let's take a look at question number 12. So these are both root 6, so that means I can add them together. So I'm going to add my integer values, so 10 and 2, which is 12, and then root 6 stays the same. For 15, when I look here, these are not the same, so that means I'm going to try to rewrite it. So 3 just stays 3, so I'm just rewriting the first term, and then for the second term I can split up 12 to 4 times 3. I do know the square root of 4, which is 2, but not 3, so this would be 2 square root of 3. Add the integers, so 5 and 2 is 7, and keep the radical the same. Okay, and then let's take a look at the back here. So let's do 23 together. So for 23, so for 75, I know that's 25 times 3. Still have a 2 here. And then 48 is 16 times 3. And then minus 5 root 3. So if you don't know the 25 and 3 and 16 and 3, you can just do guess and check. So we're just really trying to think of perfect squares that divide into these numbers. So if you weren't sure, you can say, okay, can I do 75 divided by 4? Because 4 is a perfect square. That doesn't work. 75 divided by 9 doesn't work. 75 divided by 16 doesn't work. 75 divided by 25 does work. So I'm just using perfect squares to see if they divide into each of these numbers. Okay, and then now I do know the square root of 25, but not 3. So the square root of 25 is 5, and I don't know 3. I still have a 2 there, right? The square root of 16 is 4, but I don't know 3. Okay, and then that doesn't simplify. So this is 23 still. So I can multiply 4 and 2 together. And then 8 and 5 is 13. And then root 3. And then I still have that. I guess now that I look at this, I could have just canceled that, right? 5 root 3 minus 5 root 3 is 0, and my answer is 8 root 3. So that's just because sometimes I mindlessly go through and solve and don't look ahead, which we all are guilty of, right? So I could have been done right now and just said, oh, hey, that's 8 root 3. But I didn't do that, right? I did 5 and 8, and now I'm going to go ahead and subtract. So 13 minus 5 is 8. So see, I got the same answer regardless by working left to right, but I could have just canceled that and said, oh, there's my answer. Okay, so that was 23. And that's it for Unit 6, Objective 3.